Once again, welcome to today's Research Pays Off. I am going to hand it over to Michael Vertis of MnDOT, who will introduce today's presentation topic and speakers.
Thanks, Lauren. As Lauren said, I get the pleasure of introducing our speakers today and this interesting project. Our speakers are Dr. Evan Kutai from Michigan State and Dr. Raquel Moraes from NCAT, and they're going to talk to you about the technical details of this project. But first, I'm going to provide a little bit of context and background information. So this project, the idea really started picking up steam in late 2019. We did the NRRA Flexible team did a similar project with mixed rejuvenators, where we took a common roadway and were able to insert different products into an existing MnDOT project and then monitor the performance of those projects over time. So back in 2019, we really started moving on this idea, and we had partnered with the city of St. Michael to apply these treatments on a common road, and then MnDOT and MnRoad would monitor those. As we all remember, things planned for 2020 got delayed, postponed. So COVID hit in 2020, we delayed until 2021. During that time, the Minnesota Local Road Research Board found out about this NRRA project and said, hey, we're interested. And they actually funded an additional research effort, which we'll see why we have two presenters and two researchers today. And so once there was the additional research effort, we realized that there was a lot of attention and a lot of demands placed on these sections on St. Michael, and we weren't going to be able to take the amount of cores that we needed to do kind of the characterization over time that we wanted to do. So we added sections at MnRoad. We had Caterpillar come last May 2021 and pave basically a common mix and structure for these sections on MnRoad's low volume road. And then we could go crazy, literally crazy, you'll see, with the amount of cores that we took from the MnRoad sections, but still had the St. Michael sections where we could monitor the real world field performance on a longer stretch. So in July 2021, we applied 12 products at MnRoad and at 15th Street for a total of 43 test sections created. And then in August, we took our first kind of performance set of cores at the MnRoad sections. So the LRRB portion of the study, so the LRRB is the Minnesota Local Road Research Board, which is kind of a unique entity here in Minnesota made up of cities and counties, focusing on all types of road research and everything surrounded. So pavements are just a small piece of that, but a very critical piece of their research efforts and a very big supporter of MnRoad and our low volume road. So the Local Road Research Board funded the Michigan State portion of the project, which is Dr. Evan Kutai, and they're really focused on the field performance, kind of the immediate impact related to friction and reflectivity, and then creating implementation type tools geared towards city and county engineers who are tasked with managing pavements as well as all their other responsibilities. So really what to expect when you apply these products, and then how long are they going to last. Dr. Kutai has recognized HMA experience from his time at Federal Highway Turner Fairbanks, but particularly relevant to this project is his experience evaluating chip seals and chip seal surfaces, and they were here on site during the product applications. So then the NRRA study and the NCAT team is really focused on the binder properties and the changes from the treatment. So once we spray this treatment, what does it change in the surface binder? And then really how long do those changes last? The TAP with the NRRA is made up of NRRA agency members as well as product representatives, which really give us that integral feedback loop of how we can tailor the research to best present the results and make the results usable for all stakeholders in the project. Raquel, or Dr. Moraes at NCAT, is a recognized expert in asphalt binder chemistry. I really respect Raquel. I think she's one of the few actual trained chemists in our field and not a trained pavement engineer that is trying to dust off their chemistry. So really excited to have both of these highly qualified researchers on the project. So last slide, I call it my thank you slide, but it also is my only made possible by NRRA collaboration. But like I said, the way I view the NRRA is a group of stakeholders all working towards the common goal of innovation and implementation. This project is a prime example of the power of NRRA and the influence and the amount of collaboration in the work that we can do together. I don't think any of these entities, even Minroad, could have pulled off this type of experiment or this large of experiment without the overall collaboration and environment of the NRRA. Specifically, I got to mention the product manufacturers and the representatives for those. So we had products in this study from 7 different manufacturers, 12 products total. But having all of these competitors on a common study, we haven't had any of the issues or any of the stuff that you would worry about bringing competitors into a common project and room. We're all really working towards making the research as beneficial as possible for everybody. And then lastly, the Minroad team. I shouldn't even list the names there because there are so many that helped, really from the thousands of cores to field testing to laying on the pavements. We had a fun and busy summer last year with this project, and really thanks for everybody's help. So I'm going to turn it over to Emin at this point, or Dr. Kutai. As he's taken over from me, my last little plug is we're always looking for new ideas. There's already a couple spin-off studies kind of in the works from this project in specific. But like I said, this study started as a, hey, we liked what we did on this, can we do it with these products type of idea. So keep the ideas coming, and look forward to seeing what Dr. Kutai and Moraes have to present.
Okay. I'm going to go ahead and get started. Can you see my screen and can you hear me? Michael, can you
yes.
confirm? Okay.
Yes, we can.
Well, thank you so much, Michael, for the nice introduction. Before I start with the slides, I'd like to acknowledge my co-PIs on this project, Dr. Haider and Dr. Chetan from Michigan State University. Also, our graduate student, Purnachandra Vadi, who's the person who's been doing most of the work in here. So so this is a quick outline of my presentation today. I'll be providing some information about the rejuvenators that were applied at Minroad sections and provide some videos, just very quick videos of applications, just to have so that you can have an idea of how they look. I'll present some of the results of the field experiments, application rate measurements, albedo, reflectivity, friction, as well as mean profile depth. And also we started running some experiments on the 1,000 cores that Michael mentioned. We don't have all 1,000 of them, but we have about half. And we have started testing those, and we'll show you some of the results of our testing. So in terms of introduction, rejuvenators or spray-on rejuvenators are used to revert asphalt binder aging. So I'm assuming since you are here, you know about what they are. There are many petroleum-based as well as bio-based products, and they are supposed to prolong the service life of pavements, seal minor cracks at the surface layers, reduce the permeability, and so they have a lot of advantages, and each of these products have different advantages. If there's a concern, there might be some concerns on mean profile depth and friction at the surface, and potential for excessive softening at the surface if the material is causing too much softening. So these could be some issues. So this project is going to be looking into all these and try to find some answers to some of the questions. So this is the list of the rejuvenators that were applied. We had 12 different rejuvenators. These are the names of the rejuvenators, and these are the suppliers. So I'm not going to spend too much time here. I'll let you glance over it. I will be providing some data and outputs, but I will not use the names of the rejuvenators when I'm plotting the graphs. I'll be using product A, B, and C. So that's how we are going to present today's slides. They were all applied on 2 weeks back to back in July, except one of them. One of them was ARA-TI was applied about 3 weeks later because of some scheduling issues. So we have 2 locations. One location is the Main Road test sections at low volume. The other one is at 15th Street, San Michael. This is the city of San Michael, and this is where the real-life field test sections are located. The ones in the low volume road section are actually located right here. So the ones at 15th Street is not too far from Main Road, and this is the location. So if you look at the 15th Street sections as well as the Main Road test section, so this kind of shows the locations of the cells as well as and their names. In here we had 3 controls, 1514, 1505, and 157 are the 3 control sections that were not sprayed with anything, and the remaining of the locations are all sprayed with different rejuvenators, and I'll show you some videos of those in a minute. At the low volume section and Main Road, as Michael mentioned, there are 2 substrates. One is is an overlay with 58S28 binder, and the other one is a 58H34 binder. And the test sections with the -34 are 3401 through 3415. There's a control as well there, and 3301 to 3315 are the cell numbers for the applications at the surface of 5828 binder. So now I'm going to switch to another slide to show you some applications, videos of the applications. So this is one of the applications. So as you can see, most of the applications were done on a sunny summer, essentially. The temperatures were about 91 Fahrenheit. So this particular one had a small, low application rate of about, this is the intended application rate, by the way, 0.03. This is what we were given by the manufacturer, gallons per square yard. This had some kind of milky color, and we had some wind during the construction, but not much. I'll go quickly here. This is the second product. Application rate is also low, relatively low compared to some others. So I'll go through the next one. This one is the CRF. This particular one had the application rate much higher than the other ones. So the temperature, air temperature, and surface temperature and wind speeds were all comparable between different applications. At the end of this CRF application, sand was applied on the surface. So that was one of the practices of this particular application. This is another product, Delta Mist, which is 0.09 gallons per square yard, and then the air temperature was a little bit higher, pavement temperature a little bit higher at this particular day. So I'm going to go really quick to show you all. So this was GSP 88, a little high on the application rate side, and while the material was applied at the back, there is a black coal slag was applied to provide friction. So Invigorate, this particular one was applied by hand, and its application rate ranged from 0.02 to 0.05, and the weather conditions were essentially the same. So I'm going to go kind of quick here. So Reclamite application rate, this had some brownish color. This had also similar application. except the application rates were a little bit higher. And at the end, there was a sand application as well. So this shows the sand application at the end of the application of the actual. So next one is the replay. Tiny little mist of the material, so it's quite low application rate in this particular case. So again, weather conditions were very similar. So the 25, the next one, kind of milk chocolate color, a little bit different texture. And at the end, there was an aggregate application. RPER at a relatively low application rate as well. And this is how it looked like. So those were just a few actually videos of showing how the field test sections were applied. So at the end of during the application, you've seen from the videos, we measured the rejuvenation application rate. We meaning actually the team. Michael Vertus actually measured all these pretty much. So the measurement of the application rate was based on weight, not volume. That's why I will be providing the rates in terms of pounds per square yard. So before the application of the rejuvenator, these pads were placed, and then after the application, well, obviously we had the weights before the application, and we had weights after, and then difference divided by the cross-sectional area gave us the application rates. So this slide is showing the application rates that we measured. The ones on the left shows the weight-based application rate at 15th Street and the 2 Main Road sections. On the right, the application rates that were reported by the manufacturers. This is in gallons per square yard, and this is in pounds per square yard. In terms of, as you can see, the application rates varied quite a bit depending on the product. Some applications rates were quite high, and some were quite low. And then typically most application rates from one section to another was mostly consistent, except in few cases where in certain applications rates were kind of too low. So this needs to be noted in case there are issues in the future. So next set of testing was done again by Michael and Michael's team at Main Road using a retrometer. Essentially, coefficient of retroreflected luminance was measured using this device, and this was measurements were taken at many different time intervals. What I'm showing here is one of the examples. This particular example is before application, what the CRL is, and right after application here, and at different dates and times, and you can kind of see how luminance changes with time. So there are a lot of data here. So in order to present different products, we kind of chose the very last one and developed these bar graphs. Here, what you're seeing is in the upper left corner is the 1500 sections, which is the San Michael sections. Here, 3300 and 3400, these are at the bottom two, are the Main Road sections. So you can see the measurements were made at all different locations before rejuvenation was applied, as well as after. So if you look at in this particular graph, there are quite a bit of a variation even before rejuvenation, because these strips, their reflectivity can change within a row. And so there is that needs to be kind of noted depending on whatever is on the surface. But if you look at the Main Road sections, being relatively new pavement, before rejuvenation, the reflectivity values were very consistent and similar to each other. So after the rejuvenations, some applications didn't have much effect. By the way, if you look at the first two columns, those are control A and B, so two controls. Since these measurements were taken at different times, so you can see there is some difference even at the controls as well because of the different dates. So we need to look into that level of variability as well. But if you look at some of the applications, so let's say, for example, this product A had a significant decrease in luminance. In some products had significant decrease. Some products not so much. In some cases, so we didn't have the data because, like in these two, because the application didn't go through the paint strips, so we didn't make measurement in those. So this is just the same data shown in a different way, just the difference. So if you look at the percent difference between these two, like before and after, and we sorted the data, and I just highlighted the controls so that you can see where the controls are. So you can see the difference between the different products. So as I mentioned, some products had a significant increase, as high as almost 95% decrease, and in some products somewhere in between. Some products were they didn't affect the reflectivity much. The next measurement we made is the albedo. Albedo is actually 1 minus the shortwave absorptivity. So you might be familiar with the surface shortwave absorptivity in the Pavement ME software. That is a very important input. As you can see, this is one of the SHRP 147 plots, what we call tornado plots, as shown in that study. That shortwave absorptivity is third most significant input, and in the after E star in Pavement ME. And we wanted to see if these products affect the absorptivity or albedo. So I'm going to use the term albedo as just 1 minus S is A, or albedo. Albedo is essentially reflected radiation divided by the global radiation. So we measure it using this dual pyranometer data device. So these are some of the results of albedo. And as you can see, albedo didn't change too much between one product to another in certain cases. In certain cases, there was significant change. In certain cases, there were increase. This was kind of, you would think that you wouldn't expect it to be brighter. A higher albedo means brighter color, meaning that there's more reflectance. So in like this product, in some products we had brighter or more reflectance of the light control compared to control, and that's because of the sand. So when the sand is applied on the top of the product, that affected the albedo. So one thing I want you to remember is that the lower albedo means less reflectance. That means the temperature of the pigment will be higher. So there will be more heat absorbance when you have low albedo values. So these products will be absorbing more heat compared to these products. So if you were to classify them, few of them were low values and few of them high, and the rest are pretty much the same. The next set of tests that I want to show is the sand patch test, essentially mean profile depth using the sand patch. And what you're seeing here is all the different sand patch results. Bottom line I'd like to show is that the mean profile depth values for most products, they were pretty much the same, and they were very low values if you look at the magnitudes, except in few. And again, that's also because of the application of the sand at the end, or sand or fine aggregate. You would see some increase in mean profile depth, and other than those, all the rest are pretty small change or small values of mean profile depth in all of them. So next set of tests that I want to show is the dynamic friction tester, DFT results. So the friction results were, friction tests were measured at different speeds, 20, 40, and 60 kilometers per hour. So these three plots are showing the three different speeds. I'm going back and forth just to show. The friction values before and after application, as it's similar to the sand patch results. Some applications not much difference. Some applications did have some effect and reduction in the friction, like product E and F in this particular case. In some applications, there was an increase in friction. As I mentioned, that's because of the applied sand as well. Lastly, I'd like to present some partial results of the laboratory experiments that we have been running. So these laboratory experiments that we've been running included several type of tests on the cores that we have. So we've started these tests, but we haven't obviously finished. This is the test we just started essentially. So I'm going to be providing only the tests that we are running on Hamburg wheel tracking device. We will be running all these experiments, and for the sake of time, I will not go through all these. So the idea of the Hamburg wheel tracking test is, the reason why we are running this test is that if there is excessive softening at the surface because of the application of this rejuvenator, first of all, there will be rutting compared to higher rutting compared to the control, and also we are expecting heaving that might be happening at the surface. Another potential thing can happen is, which we kind of saw, is that if there's excessive softening and if the moisture is causing, so if there's not much compatibility between moisture and that product, then the aggregates, so the aggregates would be raveling, and that would be a problem, and we actually saw some of them, and I won't show all the results here. I'll only show some of the results. What you're seeing here is the rutting data that is measured by the device itself. So for mean road sections, 58S28 and 58H34 sections. So there were a lot of data, so it's hard to present this data from this graph. So the way that we wanted to show is using these bar graphs. So we haven't finished testing for all, so we only tested 5 of the materials so far, 3 replicates each. So what you're seeing is the average rut depth at 2,000, 10,000, and 20,000 cycles. So rut depth values, so let's say if you look at one of these at the end of 20,000 cycles, control versus products A, D, G, and I, there aren't much difference, slight increase here. In some of them, there was a decrease. This was consistent in here as well. That was kind of surprising for us. We don't know yet why there would be a slight decrease, or maybe this is just a sample-to-sample variability here. But in 5834 mixes, we saw some increase here in some products. But rutting is what is measured by the device, and that device is measuring actually the deformation in vertical direction relative to the initial condition. The device cannot measure the heaving that happens on the sides. So, and we saw significant heaving in visually when you look at the tested specimens. There were a lot of heaving on the sides. So we actually use this method to measure the three-dimensional surface texture. We've been using this in chip seals and in many other applications. This method and this particular software is written by Chandra, graduate students working on this project. We essentially take a picture from many different views, and we analyze using a 3D stereo software to come up with the 3D point cloud on the surface, and we measure the amount of the maximum heave height and the rut depth from the images. So what you're seeing here is the average rut depth on the upper left corner, maximum heave height here, and the summation of those two here. So let's focus on here and here, heave height versus the total. As you can see, the heave height values in some products were quite high compared to even almost like a double in some of them. In some products were very, very similar. So this was kind of an interesting result that shows how the material is affecting the stiffness at close to the surface. I guess that's all of what I'd like to present today, and I'll be happy to get answer any questions you might have.
Hi, this is Max Berry with the Illinois Tollway. What are your plans for continued lab testing of these sections?
So one of the tests that we're going to run is this is Hamburg fixed wheel test that we had developed here in MSU, where we have a rubber tire that we replace the steel tire of Hamburg with rubber tire, and we lock it, and then we essentially run a Hamburg test, a sliding tire on the surface. This essentially is a test to see how much surface is lost because of abrasion. That's one test. Another test is the friction test we will be running on those. We have a BPT test. Another most important one probably is the bending beam rheometer test, BBR test, on the small asphalt mixture beams. So we're going to be cutting the top 3/8 of an inch samples from the top, and then we're going to be making small beams out of them. And we will be running the BBR testing on them to get their stiffness and see how they change. So that's an important set of testing we will be running. Permeability, lab permeability on the cores that we have. We will be running the permeability only just the top 3/8 of an inch or half an inch samples. We will be slicing, and we're running those tests using flexible wall permeameter. And we are looking at this imaging to see if we can see any penetration depth from the sides. We've used this method in chip seals a lot. We tried a couple of times, it didn't seem to work. We don't see much, so this may or may not go through. And we will be doing some aging study, laboratory aging on these small beams that we will be testing. We will be aging the small beams and see how the stiffness changes with time because of aging.
Thank you.
Any other questions?
I did see a question in the chat for you. MK asked, the application coverages seem different by products. Did we have various coverages intentionally? Maybe you already covered this.
Yeah, I mean, the application rates vary, and they are determined by the manufacturer. So we did not determine the application rates. So we essentially, whatever the manufacturer's recommended application rate is, we just stick with that. So it's not it wasn't our decision. So we are comparing product by product with their application, whatever the appropriate application rate it is.
And I'll just add that the application area in some of the pictures was slightly different. If it was a product that had no chance of the stripes reappearing through, then we asked that they did not spray the edge stripes. We did not repaint in St. Michael, so we did not apply over the edge stripes. So that's where you saw a little bit different application area.
Right, thank you.
So I see okay, now I can see the chat box. Let's see, how did the rutting graphs compare to the control? So here probably is the best one to show. So again, we haven't tested all of them, but this is the total rutting of the control. 3,300 sections and 3,400 sections here. Let's focus on 3,400 for now. So this is the variability. So control versus product A. We haven't done the statistical analysis yet, but visually I can kind of, by looking at the error bars, you can tell that they may not be A, G, and B probably won't be statistically different, but potentially D and H might be statistically different than B. But again, we need to do the statistical analysis to confirm that. And we haven't finished the testing yet, so we are right in the middle of the project and running these tests right now. I don't see any other. Okay, I see one more. With so many products involved in the study, do you plan to making a holistic evaluation of each product individually, or do you plan to identify which products excel in each test area? So this is, Michael, you can chime in perhaps in here, but currently plan is right now we are presenting the way that I presented without naming the products and comparing them to the control, individually to the control. So that is the current plan at the moment. Michael, do you want to chime in here a little bit?
Yes, and last question, so, and then we need to move on to Dr. Moraes. But yeah, the intention is to compare everything to the controls in the study. We are trying to provide a benefit for each individual product. The decision to use one product over another is more involved than one test result. So we have the results and we put the results out there for the individual owner to make the ultimate decision. But yeah, we compare directly to the control itself.
Okay. So I think Raquel can continue. I unshared my screen.
Can you all see my screen?
Yes,
Yes.
And we can see you and hear you.
Okay,
Yeah.
Sounds good. Thank you, Dr. Cote. It was a great presentation. So good morning, everyone. I guess first, I'm sorry for that. So just to follow up what Michael has said before, initially, this project that I'm going to be covering right now would be also including all the field evaluation that Dr. Cote just presented without having the mixture evaluation. But after we meet together, we decide to have a bigger project where we kind of divide the scope for each group or each research group to go deeper on their research. So for the NCAT team, we will be evaluating more in terms of binders properties and the chemistry of the additives, while Dr. Cote will be covering how is the whole pavement responding to the treatment. So just a quick introduction from the NCAT team. I'll be working as the PI of the project, and Dr. Fanning, also from NCAT, is the co-PI. We have Michael as our contact from En-ROAD and the NARA POC. And here you can see the list of the members. There are the top members helping in the support of the project. So just a little background, so you can understand a little bit the scope of this specific project for the NCAT team. We know that the asphalt binder that is near to the pavement surface becomes stiffened and brittle over time due to oxidation. And this type of treatments, the spray-on rejuvenators, I believe that they have the ability to modify this oxide binder that it is present in the surface of the pavement. And we, as we are familiar and we saw the diversity of products that were just previously presented, we have many products available in the market that have different chemical composition and different properties based on how they are designed. We have products that can be either petroleum or bio-based oils, and plus that, these products can also be modified with, for example, asphalt emulsions. Therefore, they would have different longevity and different applicabilities when in contact with the asphalt and the surface of the pavement. The overall motivation for this study is several points to be observed. We know that the effectiveness of these products are usually potentialized when they are applying in a surface of a pavement that is still young or in good condition. And however, we do not know yet for how long this effectiveness of these products persists after they are applied. Currently, we have only one procedure or one standard method that is currently used for evaluation of these products after they are applied in the pavement. And this standard comes from the Federal Aviation Administration procedure, the P632. That is the common procedure used for evaluation of these products in surface pavements. Our NCAT field experience has shown that even though this standard procedure can be useful, there is a lack of information because the target window for evaluation of these products when we follow this standard consists between 2 and 4 weeks of treatment application. And as you can see over here on this slide, what our study has shown is that really this limited window period of only 4 weeks is not enough to really differentiate among several products on how each one of them is able to last or to modify the binder that is present on the surface of the pavement. What our study has shown is what you can see here illustrated in this graph on the left side of the slide. We have observed that overall, the products, they have 2 stages of acting or behaving in the surface of the pavement. One stage that we call the early rejuvenation, where immediately we see after the products are applied, a decrease in the binder stiffness because, as we know, these products, they start to soften the binder that is available on the surface. And the second stage of this process is what we are calling the late rejuvenation, where because the binder stiffness starts to increase as the pavement starts progressing on aging, this decrease in the softening of the binder is product-based, and the overall difference among the different additives we can only capture after a long-term evaluation. So, as previously described by Michael, the overall objective of this specific section that is for NCAT evaluation is to evaluate over time the field performance of these 12 products, rejuvenator products, where we're going to be evaluating their effectiveness after the short and long-term application. And as Dr. Cute also covered, we have 2 project locations, San Michael and in Main Road, where we'll be working together to be able to capture all the properties of these 2 sections that are being treated. As for material selection, as you also already saw, these are the names of the 12 products that were used, and here you can see the producer of each of the products. And we have these products applied considering 3 control surfaces, where we have same containing of wrap, but we have a different base binder applied on each control section. The overall work plan evaluation consists of field measurements and also evaluation of binder properties in terms of chemistry and rheology after the products being applied. Here you can see what we'll be doing in terms of friction and reflectivity, where we'll be evaluating the control sections and the treated sections after different field intervals of the products being applied. And we'll be collecting cores also from the control and treated sections to have evaluations in the lab after extraction and recovery. So as we are familiar with one of the drawbacks when we want to work with binders that are obtained from field cores is that for us to be able to work with the binder, we have to go through a extraction and recovery process. And the extraction recovery process involves solvents that are used to recover the binder. And depending on the type of modification that we may have on the surface of the pavement, or meaning that what type of additive was used with the base binder, we can have an interaction between the solvent and the additives. And we have many researchers that have evaluated that and had shown that indeed, in some circumstances, the extraction recovery process can alter the properties of the obtaining binder. To avoid that any of the producers of the spray-on products being thinking that their products can be, the results of their products can be biased because of the solvent used for the extraction, we had contacted each one of them so they could indicate which type of solvent they would have a preference on using. And here you can see that the majority of the producers had agreed with using trichloroethylene, that is the common solvent used for extraction of binders from field cores, and only 2 of them specifically request different solvents. And this is just for information whether you can see which kind of solvents will be used for extraction of the binders from the field cores. So after we extract the binder, here we have, we will be evaluating the material properties as mentioned previously, considering the rheology and the chemistry. For the rheology part, we will be evaluating control sections, meaning that the sections without any of the products have been applied, so that would be our baseline, and we will be evaluating the treated sections. The overall properties that we will be observing from the control and treated sections are listed here, where basically we will be measuring viscosity, measuring superphase performance grade and MSCR, also evaluating low temperature properties using DBR, and the DSR also for frequency sweep construction. What I would like to highlight here that you see on orange is that we will still be using the parameters that are required on the previous standard that I have mentioned, the FAA procedure, just for us to monitor based on the specification that is currently used. And from the chemical evaluation, oh, and I'm sorry, I forgot to mention that as you can see here, we will have the application evaluate, the surface of the pavement evaluated after the products being applied and exposed to field age interval of 1 month of the products being applied, 12 months, and 24 months. So we will see how these treatments are progressing in restoring binder properties or when they start to lack effectiveness. From the chemical point of view, the same binder that was extracted and recovered will be evaluated using FTIR, so where we can be, that is Fourier transform infrared, where we can be evaluating oxidation products in terms of carbonyl and sulfoxides, where we also will be monitoring the control sections and the treated sections after subjected to the same field interval used for the rheological evaluation. And additionally, we will be evaluating the SARA fraction, the saturated asphaltenes, resins, and aromatics, how to see how we can capture how each of the products is really interacting with each of the fractions from the base binders. And hopefully, the overall findings of this study will help us to really understand what are these products really change in our asphalt surface and try to capture for how long the change that they provide can really last, and which properties we can be trying to evaluate to really see the benefits of these treatments. As you can see here, we have the schedule of the project. As Dr. Cute presented to you data regarding after the products being applied, the NCAT step on the study is going to initiate now. We have the cores that after 1 month of application, they were collected. We are waiting for this course to arrive at NCAT so we can start the binder extraction to start to evaluate the rheology and the chemistry. Hopefully in this coming month, we will be receiving the course so we can start to generate some data. And with that is what I have to present today. And if you have any questions, please let me know.
Raquel, there are a couple of questions on the chat box. I don't know if you can see the chat box, but
yes, I can. So, is there an optimal age or pavement condition measurement? Excellent question. So, what our study has been shown here at NCAT test track, we have currently three sections where we are evaluating 6 products applied. What we have been observed so far, if the surface of the pavement, we try to always use a surface that has no visible distress because that influences also on the results. And also what we have observed is that pavements that are maximum of 3 years after construction are the best starting point for application of this product. If we have a pavement surface that is too old, let's say, the effectiveness of these treatments do not last as long as if they are applied in a pavement that is not that oxidized or that old after construction. So our study is indicating that indeed it's better if we are applying these products in a pavement that is not has not more than 3 years after construction.
And I'll just add that the pavements used in this study were 1 year for the St. Michael section, and then only a couple months old at Minroad. So we paved a couple months before we applied the spray treatments. And part of that decision was reaching out to the individual participants, asking their feedback. And when we were trying to find a road in St. Michael, we're really targeting something that was 1 year old. And I specifically asked if we had to go the other way, would you prefer something that's a couple months old or 2 or 3 years old? And they said a couple months, it's better earlier than later.
Yeah, in this, I'll give an example of something. For example, we have a specific product that we are evaluating 2 sections. One that was constructed 10 years ago and one that was constructed 3 years ago. We see the same product being applied, the same design, the OGFC section, and we see that on the section that is 10 years old, even though you still have the effectiveness of the product being applied, the duration of this product being reacting on restoring the properties of the binder is much shorter in comparison with the section that was 3 years old constructed. So what the conclusion that we are coming to see over and over with the field data is that if the surface where the treatment has was applied has a long time or oxidation is elevated, the product would need to be reapplied faster than a pavement that was treated at a younger age. What are the important factors to identifying the timing of application and what kind of products should be applied? Well, just as I mentioned to you, we look for surfaces that do not have visible distresses and to try to see how old is the pavement in terms of how many years after construction. And regarding what kind of products should be applied, that is a very tricky question, right? So what we are trying to see is, for example, that I would say like this. We have products, as we mentioned, that could be petroleum-based or bio-based. So the choice of products to be applied, for us not to say which one is better or worse, it's not the case for that. But to say like when deciding what kind of product to be used, we see that depending on the chemistry of the product that you're going to be applying, your application rate is going to be different. So that's why when Dr. Kute was showing, you see like several of them have a high application rate, where other ones has a much lower application rate, and that all comes from where are the base composition on all of them. So that's where influence how the residuals is going to be on your surface. So we have to have all of that information in mind when selecting a product to be applied. What was the control only recover with the trichloroethylene, or were the other two solvents also using the control to understand if the different solvents have impact on the baseline? Or we were doing recovery of all the products because to see this? That is an excellent question, and it was also something that was thought by the research team. But we have limitations on how we can have the number of cores extracted, and also the budget-wise of the project. So we had to have a cut on it, even though it is known that we can have influences of the solvent. We have to stick with the majority, as the majority of the products selected the trichloroethylene. The control would be using the solvent that is being used for the majority of the products. I guess I don't see any more questions, Michael.
I don't see anything else either.
Well, thank you very much for the questions and for the opportunity to work with this very interesting project.